Hello, everyone. So we're ready for the next presentation, and I would like to welcome new attendees to the Enhancing Clinical Practice and Outcome stream of the SNOMED City Expo 2024. My name is Anne Randolph-Hoyen, and I'm an implementation support specialist with SNOMED International, and I'm moderating today's session. All questions will be answered at the conclusion of the presentation, and for online attendees, please use the Q&A button to type in your question to the presenter, and for on-site attendees, please use the microphone provided. So now I'm welcome to introduce Dan Huff from University of Utah School of Medicine, who will be presenting greater use of post-coordination in the LOINC SNOMED Ontology. Stan, please go ahead.
Thank you. It's a great pleasure to be here, and it's great that I came because there are all kinds of related things that are going on. The talks that have, and Anna is very familiar with the context concepts within SNOMED, and then what Christine presented, all are starting to have a lot of similarity in concept. So excited to be here and present a little bit about our thoughts from the LOINC perspective. Now, can I advance? Yes, no, let's see. There we go. So the very first thing, I just wanted to establish that the goal I have in talking about this is semantic interoperability. And then I wanted to be a little more specific. Oh, there we go. Did they advance or did I advance? Anyway, I wasn't done with that slide. So nope, that's going the other way. I mean, if somebody's got control, I can just say next slide when I need to, or yeah. There. Okay. Okay. Great. Semantic interoperability, in the way that I think about it, have a very specific goal in mind, which is that you have a formal enough definition of data, in fact, essentially an exact definition, so that as a foundation, people can build on that and create applications that can be used anywhere that the standard is supported. And so it goes a step beyond what typically is described here. It's not just the ability of the computers to understand the data. It's actually at a level that you can create an application or an analytic query or other kind of capability and use it over and over again everywhere without modification, without changes, without local mapping to particular systems, et cetera. So that's where we're trying to get to. And I don't know, I just magically, my finger doesn't work when it. Can you just do next slide for me? Thank you. Yeah. So yeah, next slide. Okay, so now into the part about greater use of post-coordination. Next slide. So to get to that level of plug-and-play interoperability, there are at least three things that are needed. One is a single preferred presentation for a given kind of measurement, assessment, or conclusion, and then that data representation requires structure, standard terms, and binding of the coded attributes. In other words, the value set to that coded attribute. And we need detailed clinical information models that allow you then to convert between pre and post coordinated forms. I'm using different words than Christine, but it's really the same principle behind this. Next slide. So just so you have an idea of what I mean by an information model, this is a clinical element model. And what it's showing basically are all of the elements that are needed to define data instances. And you'll notice that it's not only, if you will, sort of the semantic information, but it's also provenance information and other things. And so things like comments and the patient's identification and all of those things are also part of the model, because it's real world data. And if those parts aren't consistent, you don't still have plug and play interoperability. This is a model then, next slide, but you have a binding between the elements in the model and a LOINC code. And then down here, next slide, you have the value set that's allowed in that model. And so these things taken together create a uniform presentation of the information that you want to share. Next slide. Okay, so two things you need then. You need a way to decompose things into those common structures, and then you need detailed information models for the resulting post-coordinated representation of information. Next slide. Okay, decomposition. Next slide. So a foundational principle of LOINC basically is that a LOINC code should refer to things that have the same clinical meaning. And there are lots of details around that. It's easy, for instance, to implement that rule when you're talking about things like serum sodiums and serum sodiums and urine sodiums. They both have to do with sodium, but in fact, clinically, you would never, you would never interchange or use different. You would always use a different code. Well, excuse me. Serum sodium is just a very completely different data element than urine sodiums. So you'd never have the same LOINC code. On the other hand, you can get into sort of gray areas when you start saying, was this LOINC code, or excuse me, was this particular, oh, we went ahead once. Wow. Get back. You could look at a bilirubin though, and there are different ways to do bilirubins. And in fact, people find out that there's different reference ranges based on that. So then you can argue that, well, it's not really clinically the same thing because I can't interchangeably use it in the item. So a basic principle, and I think this was borne out as well by Christine, is that all of the information you need to make data interoperable and interchangeable doesn't exist in the single code. Essentially, what you would be doing then is sort of have a dictionary, and you're making up sentences for every single thing that you do, and that's not a sustainable approach. So what you're allowed to do is, and when I say that, and then assigning a code to the sentence, not to each of the elements in it, but assigning the code to the sentence and trying to exchange. So you also need a principle from LOINC from the very start is that all of the information you need is not in the LOINC code. You have to add other things. At a minimum, you need to add unit of measure for quantitative elements, for coded elements, you obviously need to know the value of the code. But there are other things like the priority of the test that was done, the kind of instrument or device that was done. It came out with COVID that you needed to also know the kind of reagent, who was the source of the reagents, because the reagents themselves had different sensitivities and specificities, et cetera. So we want to use LOINC codes to represent the data in the patient's data stores, not just in data exchange messages. So there are exchange syntaxes, and then you also have data at rest, if you will, and there's no reason that you can't use the same model for both things. So, whoops, went the wrong way. So the challenge basically, or maybe the trade-off, is to know how much information to put into the meaning of the LOINC code versus how much information you send along is in other fields in the data representation. So if you look at LOINC codes relative to systolic blood pressure, there are 122 active concepts around systolic blood pressure. And there are good reasons for all of them to be different, but that becomes a challenge to start then comparing things and knowing when things are comparable and not comparable, et cetera. So if you start looking at just a small sample of those codes, what you see is that they all have to do with intravascular systolic pressure, and they all are measuring a pressure at a point in time in the arterial system, and they're quantitative measurements. But what you see is that there are differences in invasive, non-invasive palpation, different methods by which you can determine that. And then you also see in the first part there that there are sitting blood pressures and standing blood pressures, et cetera. And so there are things that you want to do. And so what we're proposing basically is to say, look, think about that code and add some information there that says blood pressure method, and define a value set for that that would contain all of the allowed values in the context of this specific measurement for that code. And the same thing for things like sitting and standing, which would be patient position, et cetera. So when you apply that to data instances, you have essentially a pre-coordinated option, that's option number 1, and you have a post-coordinated option number 2, which is the preferred option. So in the first option, you've got a single LOINC code that says systolic blood pressure sitting. And in the second one, you have systolic blood pressure, more generic code. And then you have 2 additional pieces of information that are included in the data representation, one that says it's non-invasive and one that says that the patient was in the sitting position. Now, my example is bad because that invasive thing should also be over here in first option. So ignore that. But the idea is now, and that I can actually go both ways. If I have that post-coordinated representation, I can combine those concepts, and I know that defines exactly the concept that's in LOINC and vice versa. And then just as an appropriate practice, you carry the code over. If you receive that pre-coordinated code and you store it in your database, then you want to store the code in your data, so that if for whatever reason you misinterpreted that meaning or made a mistake in how you transform the data, then you could recover from that error because you know what you received on input. So another example, this is even a little more extensive. This is about bacteria identified, in other words, and it's by various kinds of cultures and other things. And we're doing the same thing here and saying, oh, let's post-coordinate the specimen type, for bronchoalveolar lavage, blood, sputum, et cetera. And then have also the culture type, if you will. So when you look at the instance of the data again, you've got the bacteria identified in sputum with the respiratory system culture. And in the post-coordinated representation, you've broken out and said, well, I'm doing basically I'm identifying bacteria that I'm doing it though in sputum, which is specified in a separate field. And then I'm doing it with a respiratory culture. And so that represents then the same identical information, but it does it in a post-coordinated way. So that's how we do the decoord population. So the actions that we take actually in the LOINC system, we keep doing basically what we've always doing. We're making pre-coordinated concepts when people need them and ask for them. But we will always make sure that we make a generic code, and we will, for that generic code, we will make the value sets that allow you to express all of the information that was in the pre-coordinated code. We won't delete any existing pre-coordinated concepts, and we won't automatically make pre-coordinated concepts that nobody asked for or any of that kind of stuff. And then an essential part of this is that we need to have a mapping, actually have a public mapping that shows how you can move data from a pre-coordinated representation to a post-coordinated representation. Now, I'll say a little more about that. So the information model. So in order to have this be comprehensive, you know, the things in LOINC are pointing you to value sets and things that you can post-coordinate, but LOINC wouldn't have all of the things that you need in an actual data instance. Again, there's provenance information and other things. And I mean, it could be in LOINC, but in the way that we've done it with, you know, the XXX values and creating those value sets, you can't do that for things that haven't been part of LOINC traditionally. So you create an information model, and I think this corresponds to what Christine was talking about as Tinker. I don't know if it was the template or the concept, but what it really says is these are all of the things. So you make a comprehensive model that says, you know, you've got a LOINC code, you've got the original LOINC code, then you've got the value, the unit of measure, the threshold, the cutoff, the interpretation, the reference, and all of the kind of information that you want there. And you also have the provenance information, how it was collected, who collected it, when they collected it, what laboratory did the test, all of that sort of stuff. So you have a library of these kind of models now that are putting things together, so you know all of the pieces that are available to you. But then when you apply that in a particular situation, you make a constrained model. And so you have the LOINC code, and in this case, this is an example for Neisseria gonorrhea DNA. You have the LOINC code, then you have the value that's going to say positive or negative, and that's a value set associated with that. But in this particular case, for instance, the unit of measure and the threshold or cutoff are not used. They're not applicable in this circumstance. But the interpretation is the reference range, not necessarily used in this activity, but method is absolutely essential. And you'll see that some of the things, if you will, are required and optional. And then there are other things that are essentially not available, never apply. So the public map again comes back to this, that you know, the pre-coordinated code is in that second column. And then what you're seeing in the subsequent column is what code would you put then as the primary code, and what field in the output. You know, aggregate basically stands for what code that we call the pre-coordinated code, the aggregate code. And then for method and describing in the method what needs to go in that field. And so that's the kind of map. This is simply done in a spreadsheet. You could do something much more elegant. I have to say, I'm sorry for how ugly my slides are. I have slide envy for everybody else that has pretty slides. So anyway, this is just, we're short of time, so let me jump. Being able to do that pre-coordinated and post-coordinated representation, you can take essentially 3,700 pre-coordinated representations for laboratory data, and you can turn that into 900 models. So it's basically, you can represent the same information tremendously more simple by doing this pre and post coordination representation. So why? Because you know, it makes the data easier to query. and use in decision logic and other purposes. Because, for instance, with the bacterial identification, you can search for one LOINC code and it will find all bacterial cultures. And then you can sort the data based on the other attributes. If you only care about sputum cultures, or you only care about blood cultures, or you only care about the ones that were done by a respiratory culture, et cetera. And it makes it a lot easier for people to choose the right LOINC code if you don't have as many LOINC codes with all of those additional pieces of information on it. It's easier to maintain the queries as well, because in the queries now, it would be really rare that you would change the primary code that you're searching for. What you'll do is just slowly accrue other additional information that people may want to know about that item. And that's much easier to handle and compensate for when you're programming clinical decision support. So, that's kind of all I wanted to say to start with here. And I'd welcome questions.
Thank you very much, Stan. And we have questions here in the room.
Don't let Daniel ask questions. I don't know.
I'm Dr. Lee from Taiwan. I'm a GP. About the LOINC application, what I am thinking about is a very ordinary and a very frequent use is blood pressure measuring. Then we know up to now, the blood pressure will be divided into home blood pressure, which is most recommended for to decide which the patient is hypertensive or not. And the other side is official blood pressure. So basically, the blood pressure measurement, whether the device is it is used, basically they define into very different two categories about blood pressure. And it is a clue for blood hypertension diagnosis. And side is there's also the problem of a device. The device use traditional mercury, and which will be abandoned but still in use. And the other is the bioelectronic device, which will be most useful in the future and now. So, but this different device also produce the different, for the same patient, same time, there will be a different value, and it will be different remarkably for diagnosis. Then about the measure weight, we know about the same electronic blood pressure device where there were two basic different patterns, which we don't say about the Apple Watch, but even the commercial available blood pressure measurement device, they were used in the wrist and using the arms, which for arms is most recommended, and for wrist is not recommended. But it is commercially the same on the market. So when we see the patient, we have to know what kind of device he used and where he used and how he used. So it will be the different result.
Yeah.
So
let me
how
answer
do you
that.
solve that?
That's exactly what this is showing. Okay, so when I say that this blood pressure model is specific to this this particular thing, if this were systolic blood pressure, all of the things that you said would be here. And the things that you care about, whether they're sitting, standing, whatever, you can change whether those are required or not required based on whether you're doing a hypertensive study or whether you're just doing routine blood pressure measurements, you know, in the hospital or in the operating room. And so there would actually be a unique model for blood pressures that you're using for hypertension diagnosis, and a different model with different requirements for all of the elements when you're in other contexts. For instance, if you're doing orthostatics, Orthostatic blood pressures, you would say it's required to know the patient, whether the patient is sitting or standing, et cetera. And for the nuances of those things, there would be an element here that would say the protocol. So for instance, if it's not just the device, but it is actually the protocol that says the patient has to have been sitting with both feet on the floor before we take the blood pressure, and they have to have voided within 30 minutes before the blood pressure was measured. So all of those details would be represented in this specific model. And so there would be multiple models for blood pressure, but the thing that would be consistent is anything that appears anywhere would have the same identifier. So patient position is the same, whether it's part of a whole bunch of different subtypes, or the device has the same meaning, even though the values of the device might be different, et cetera. So very good question.
Yeah.
Go ahead.
So first, thank you for a beautiful presentation. I didn't see any problems with the layout, and if there was any, well compensated by the content. So thank you very much. I have a question. So we had some experience at a presentation yesterday about trying to do something like coordinating between different attempts at representing histopathology content for breast cancer research, and we kind of got stuck where there was not a good agreement on the logical model. So it's like we have experience of standardizing the implementable specifications like fire profiles and resources. We have experience of standardizing terminology, like there's many attempts, and but like standardizing logical models, how do you think we should go about building standards also for these specifications?
So, I mean, basically the way you do it, and it may be iterative, is you note all of the things that you know are going to be important to people, and put them in the model, and then as you go along, I know that, we had systolic blood pressure models, and then we said, oh, it's important to know whether they're sitting or standing. Then we didn't go too far, and somebody said, well, it's really important whether they were exercising, or, it was at rest, or it was pre and post a treatment, et cetera. And you can add those in, and then you start constraining out things. But maybe the overlying or most important part of that is what I said about allowing more than one representation, because I've never been able to get everybody to agree on one way to model it, and it's actually true that different models are more convenient to use in different circumstances. So not so much in lab data, but when you get into entering the kinds of things that you were talking about for diagnoses and physical findings on patients and pathology result findings, what's important is that if people want to model it differently, as long as it has the same meaning, you're okay. If it doesn't have the same meaning, then something's missing and you need to fix that. But if they want to, and what you do then is again, make public maps, so that if one group of people just have to see the model this way and another group want to see model, a different way, you just make a computable map between that. And you can even imagine that we would have an API that says, oh, I've got this data, and you call the API and it'll return the data in the other form. So you don't want to have a lot of that. You only want to do it when you need to. But when you need to, then as long as they really have the same meaning, there's not a problem to using two different models for the same data. Because I've never been able to, I would wish that I had been granted power to make people do what I said about, and it's never happened. I don't know what's wrong, but anyway, but that, I don't know if I answered exactly what you were asking, but it's really in that it's okay to have more than one representation as long as all of the information is represented in both models, and some of it might be pre-coordinated or post-coordinated or have a different unit of measure or something else. But then you can just transform it when you want it in the other form. And it's unrecognized synonymy that's kind of the enemy of all interoperability. So.
Thank you very much, Dan. You certainly clarified things for me as well. Thank you very much. And with that, we'll conclude this session, and you can move to another room, or you can stay here and listen to the next excellent presentation that we have in line.